Swayam Prabha. Digital India. Educated India.
Hello everyone. So, we will discuss now the modified air filtration apparatus which was developed in house. So, here in this modified air filtration apparatus, the construction will be almost similar to that we have discussed earlier, which was working in the principle of gravimetric measurement of the dust particles. Here in the modified system, what we have adopted here, the number of particles we have measured. So, operation of dust feeder, control of operating time of dust feeder with the software. So, here the dust feeder, the speed or at which rate the dust will get fed, which is controlled by the software. So, then online measurement of filtration efficiency, we can the real time we can measure the filtration efficiency with the time. So, here online measurement of particle concentration above and below the filter medium, that is important. So, here this is the filter medium, okay, and at the upstream side the particles are there, this is the particle, and then downstream side, and there will be two separate the particle counter. This is the particle counter will be there, one is in the upstream side, another is in the downstream side. This particle counters measures the particle number of particle per unit volume. So, and in the downstream side also this will measure the number of particles in the downstream side per unit volume. So, this ratio will be expressed in the in terms of filtration efficiency. So, number of particles, okay. One sensor of the particle counter is fitted on the upper side of the vertical pump, okay, that is above the filter, another is on the below the filter. Test dust is added to the particle free air. So, initially we consider that the air is particle free. So, test dust is added, okay, after which the particle counters are used to measure the number of particles here. So, this is the system here, dust feeder is there. So, here similar arrangement, but here the dust feeder is controlled by the stepper motor is used, this is controlled by the software. So, which we can change the dust feed rate depending on our requirement here, and this is the vertical count. Here you have the two particle counter, okay. Particle counter is there, and pressure drop is measured by the inclined tube manometer. So, the construction is overall almost similar to earlier equipment, but here we are measuring the number of particles. Another system was developed where the tube, the measurement is in the horizontal mode, where the air is flowing in the horizontal direction and filter is placed. Now, it has got different components. First is that aerosol particle generator. Here this is the aerosol particle generator which generates the air the particle and mix with the air. So, the dusty air flows through the duct. This is the duct where the dusty air flows here, and there is a differential pressure gauge which measures the pressure drop across the filter. Sample holder with rubber grip. This is a sample holder which holds the filter fabric or test sample, and here 5 is the upstream particle counter. This is similar to the earlier instrument which we have discussed based on the particle counter. This instrument also works on particle counting mechanism. So, upstream particle counter is there, number 5, and 6 is the downstream particle counter. This is the downstream particle counter, and here the flow meter is there 7, that it measures the air flow rate, and flow valve controller. So, it will control the air flow rate. If we want to change the air flow rate, that we can control by this valve, and 9 is that is the suction pump. So, suction pump is moving running, and air flow meter control, that control through the controller we can change the air flow rate. And then test media, this is the test media is there, whatever the filter fabric we have used, and this system was basically here we can use any thickness. So, very thick nonwoven can also be used or any other medium. So, filter life is actually, this is also known as the dust holding capacity of filter medium. This is basically the amount of debris the filter medium traps and holds before the fluid flow is restricted. So, it to a greater level, because it is so that the pressure drop becomes very high. That means, there at that level we cannot run the system filtration system, the filter fabric needs to be changed. That is called the filter life. Grammage means that is the weight per unit area, which is simple mass per unit area we can get the for filter fabric, which is all important. We can call it as basis thickness, basis weight, and thickness or caliper we can get the thickness measured as per the standard distance between the two surfaces. Bulk density or bulk we can calculate, its density is defined as the weight per unit volume. This is the density mass per unit volume. We can just get in terms of, if we get the grammage and if we get the caliper thickness, the ratio will be the density, that from there we can calculate for a certain area. So, bulk is the reciprocal of density that we can get. So, basically it reciprocal thickness per by areal density, that we can get the bulk, which is important. Bulk is important to get the filtration efficiency along with the particular the pressure, it will give the indication of the pressure drop also, solidity or porosity, the how much porous the filter medium is, that is expressed by the solidity. So, it is defined by the ratio of the volume of solid, that is material, to the volume of air, that is the porosity of the filter medium, that is volume of the fiber, and this is the volume of the filter medium. So, mass is there, and if we that is a Vf and weight, and from there we can calculate, because if we the fabric mass and fiber mass are same. So, fiber mass that is mass, then we can multiply by the mass of the fiber or fabric, and then mass per unit volume of fabric. So, this is the mass per unit volume of fabric and mass per unit volume of fiber, that is the density of fiber, and from there we can calculate the density, where this is a gram per, this is the volume. So, from there we just by rearranging the equation we can calculate the solidity, where mu is the solidity, Vf is the solid volume, fiber volume, and porosity is basically it is a 1 minus mu. Solidity and porosity we have calculated. Now, try to understand the structure of pore and how the pores are size are measured. So, the structure of pores, pores are of different types. One is the pore is a closed pore, where the pores are generated within the structure. So, it has not started anywhere at the surface. So, this is the say one side, this is the other side. So, that way. Another is called blind pore. It starts from one surface, one of the surfaces, and it ends within the structure. So, it is not continuous. And third one is that it is called through pores. It starts from one surface and it continues without any breakage, without any discontinuity, it goes to the other surface. So, this is called through pores. So, these three types of pores are there. Now, the pore structure is measured by the porometer. So, porometer is the instrument which works on to measure, which is used to measure the pore structure. There are different types of porometers are there. So, it measures the, it is a membrane and the filter characterization technique. So, membranes pore size or filters pore size we can measure here, and it works on capillary flow principle and used to measure the pore size or its distribution in a filter medium. So, that is the different pores that there are different methods. So, first method we will discuss is the intrusion porosimetry. So, intrusion porosimetry is the where mercury is used. Now, here it is a mercury and it is a contact angle. So, contact angle, if you see mercury contact angle, it is more than 90 degree. So, here it is an 90 degree is more than. So, it is it does not wet the surface. So, we have to force the mercury through the pore. So, pressurized mercury is forced into the pores, that is cavity of any porous medium. So, this mercury is forced to the cavity and the pore dimensions are calculated based on the penetration pressure. Like if the pore diameter is small, so for to penetrate a certain quantity of mercury, we need higher pressure. So, that by measuring the pressure required, we can calculate the pore dimension indirectly. So, this is the principle of mercury intrusion porosimetry. Another method is physiosorption. So, physical adsorption is there. So, that principle, through that we can use the internal pore dimension. Here you can see that adsorbed liquid nitrogen. So, liquid nitrogen is actually used here and it gets adsorbed at the surface of the fiber. So, the pores are there. So, at the surface the liquid nitrogen gets adsorbed. So, liquid nitrogen is adsorbed on the surface of any porous solid material, maybe fiber, maybe any other porous material, and this allows to calculate the surface area and dimension of the pore of the material. So, here if it absorb more liquid nitrogen, and then there will be, that means it will have more higher pores. So, depending on the amount of liquid nitrogen adsorbed, that will give us the idea of the what is the dimension of the pore. So, that is the another way of measurement. And third system, which is very widely used in textile, that fiber in nonwoven fibers pore measurement, fibrous materials pore measurement, it is liquid porometry. So, where this is the liquid porometry. So, a wetting liquid is dispersed from pores by another wetting liquid having higher surface tension. So, first we will have it will wet the fabric with a liquid with a lower surface tension. This is the with a lower surface tension, and then a liquid with higher surface tension is forced. Okay. And depending on the pore dimension, the pressure will be changed, that which pressure it is there. So, here the very low liquid flow rate are measured using the liquid flow porometer and micropole lens. So, that means the pressure means here we are applying certain pressure. So, that will actually generate certain flow rate. So, depending on the dimension, the flow rate will change, that flow rate, liquid flow rate is measured. Okay. Here, and another is which is very widely used is capillary flow porometry. This is mainly used in case of textile materials to measure the pore size. This is the capillary flow porometry principle. So, wetting liquid is there and non-wetting liquid is there. So, two types of liquids are there here. So, an inert gas is used to displace the wetting liquid from the pores, and gas flow rate is measured using the flow meter. So, here a wetting liquid is there and the gas flow is measured, inert gas is actually passed through that. Through the liquid, the wetting liquid is the wetting liquid. What is the wetting liquid? Wetting liquid actually, when we drop the wetting liquid on any textile material, it will occupy the pores within the structure. The pores will be occupied by this wetting liquid, and then what we will do, we will actually then flow the one inert gas, which will drive out this liquid from that the pores. That flow actually flow rate we can measure using the flow meter. An inert gas is used to displace the wetting liquid from the pores, that is from this pore we can use one inert gas to displace this. The gas flow rate is that its gas flow rate achieved at a certain pressure is measured. Okay. So, that we apply certain known gas the pressure. So, gas flow rate is measured only, it measures only through pores, not the blind pores or closed pores. So, the pores which are throughout the one surface to another surface, that only we can measure. Sample is weighted with the liquid of low surface tension and low vapor pressure. So, consequently, all the pores are filled with the liquid, and then it is subjected to the increased pressure by the inert gas. So, when P gas is more than the surface tension, then it is pushed out, that the liquid will be pushed out and it is increased further, the gas flow through the small pores until all the pores are emptied. So, you are getting all the pores emptied, and that will give indication. So, wet run, when monitor pressure of gas applied and flow of gas when liquid is being expelled, and also there is a dry run. So, without any liquid we run this process and we measure the flow rate at certain pressure, and the ratio this from this two data we can calculate, we can get the idea of the pore dimension. So, pore size distribution. So, by comparing the wet run and dry run result. So, there are different parameters which can be measured. One is the first bubble point value, the pressure at which the first continuous gas bubbles are detected, that is first bubble point. Next is the smallest pore size we can measure we can measure the mean pore flow pore diameter, that we measure. Okay. Gas permeability we can measure using this instrument. Cumulative filter flow we can measure, differential filter flow we can measure. So, and correlated differential filter flow. So, corrected filter flow we can measure. So, we can from this capillary flow porometer we can measure different characteristics of the filter structure or any porous structure. Dimensional stability is also important, tensile strength is very important, which is measured by strip test. Normally ASTM method we follow. Graph test is also important, many other standards we follow. Testing mechanism, constant rate of extension, constant rate of loading we can follow, and constant rate of traverse. So, any method we can follow. The result is a breaking force, breaking elongation, modulus, in this term we can use. So, tear strength is typically different types of tear strength, tongue tear strength we use. So, constant rate of extension is applied, maximum force we can get, normalized, often normalized for the weight, average force we can get sometime. So, bursting strength is also important. So, here this perpendicular pressure is being applied. So, and when we divide the bursting strength by the grammage, that is mass per unit area, we get the burst strength. So, that means higher the grammage, definitely the bursting strength will be there. So, burst index we can calculate by the ratio. Now, we will discuss different products. So, from the whatever filter medium we have discussed, we can actually get different types of products, which is actually which are used in the industry or in different areas in residential applications. So, these products are basically based on different shapes. We can create different shape of the product depending on our application. First is the flat filter, where the very stiff filter medium is kept in a flat form. So, this is a filter medium, it is a bulk filter or it may be thin filter. For bulk filter we may or may not need any support, but for thin filter like textile fabric, oven fabric, okay, oven fabric, there if we want to keep it flat we need one frame support, and in which we can keep the textile or fabric. So, thin filter we may need support, and the bulk filter we do not sometimes need support, very stiff. Now, flat filters are used without any frame, okay, or for bigger size. So, that may be that held by the rigid frame or supporting grid. So, for bigger size we need some support, but for smaller size, if we use a very small size we may not need the additional support, like vacuum cleaner, where we need a stiff fabric, stiff filter, but we may not need any support, we can simply place the in the particular position. they would be divided into two variants. One is bulk filter, that is they are a thermal or chemical bonded nonwoven which are stiff or very thick needle punched fabric, and thin filters which are flexible, that is woven fabric or knitted fabric or spun bonded or melt blown fabric. There in those case we may need the support frame, but in bulk filter we can then where if it is a very bigger size, there we may sometime need the frame. So, typically it is divided into two types, one is bulk filter and thin filter, and you can see the application of flat filters. So, cheap filters for common application of vacuum cleaner, kitchen digester, paint box, okay. These are where we need to filter flat filter. Okay. Then plated filter. Plated filter is basically derived from the bulk filter. Now, the difference of bulk filter for flat filter. So, this is a flat filter here, and this is a circular flat filter with diameter d. So, it has got its own cross sectional area. Okay. Now, here if we can, and that air flow rate will be limited, and as the cross sectional area is less. So, for certain pressure, certain flow rate, flow velocity, that certain force, so pressure drop will be high. Now, if we can create larger size, if we can with the same dimension, if we pleat it, pleat the filter. So, there the actual area of the filter will be larger, very high, and so that for same flow, that thrust, the pressure will be less, and also it will have more filtration surface which will actually arrest more particle. So, filtration efficiency will be higher with lower pressure drop. So, this is the example. Another advantage here, where the space is less, with a smaller space we want to have more filtration efficiency with lower pressure drop, there we can get the this type of pleating. So, a flat filter we just make a pleat and it is hold by the, it is actually gripped in its position by the rigid frame. It is placed in the rigid frame is there, and this is the filter, and total this is the filter setup, where we can increase the thickness of the filter fabric. This is the effective thickness, although the individual fabric thickness is, it is very thin. Now, here the effective thickness is little bit it is increased based on the pleating, and it is suitable for highly efficient filter, mainly we used in various applications like automobile we use, where space requirement is less. So, pleating process leads to bigger filter surface, which results the lower pressure drop, and also the lower pressure drop also higher filter surface means it will be able to filter out large amount of particles. It is possible to pleat a flat material for which stiffness and elongation are similar to paper. So, that we can pleat. So, wet lead nonwoven we can from glass fiber, this type of stiff material we can pleat. So, here one thing is that important here in for pleating, if we want to have the stable structure, we need stiff material, and it is hold on a rigid frame, and filter thickness is usually 1 to 3 centimeter, that is the filter thickness. Effective thickness will be 1 to 3 centimeter. Now, induce it is used as pre-filter, HEPA filter we can use, okay, and used in air ventilation, air conditioning system, auto cabin air filtration we can use, industrial application, respirator for home mask. So, half mask that we can use definitely we can use for the places where you have the space constraint is there. Another is pocket filter, which is similar to air filter, sorry, pleated filter. This is the pocket filter where pocket is generated. Okay, this is a pocket is generated, and similar to plated filter, but only the filter thickness is higher than the other filter dimension. So, here the filter thickness what we get, it is much higher than the plated filter. The advantage here we get, here the total effective area of fabric is very high. So, we get the very low air pressure. So, very high pressure, high speed, at very high speed we can filter with a low pressure drop, and also the very high filter surface is presented. So, generally it is possible to use nearly all filters. So, it is not necessary it has to be stiff like plated filter. The pocket filter it forms the pockets. At first they are stitched and or bonded. So, you have to stitch or bond the pocket, then it is embedded in a frame. This is a frame is there. First we have to stitch the fabric to form a pocket, and then we are fixing it on the frame, and the dimension is big. So, that is the disadvantage for a place where the space requirement space is a constant. So, this type of filters, pocket filters we can use in large industry, but not in the cabin, like in automotive cabin we cannot use this type of filter. So, it is used for as a pre-filter for plated HEPA filter or final filter for less superior industrial application. So, for industry application we used this type of pre-filter sorry pocket type of filter. Next is that cartridge filter. Cartridge filter is used where we need very compact filtration. So, a flat filter or pleated filters are wrapped around a perforated tube. So, if you see this is the perforated tube, these are perforation, this is circular cylindrical tube and a flat filter, this is a flat filter or plated filter. Plated, there these filters are wrapped around this perforation, and where the dusty air or polluted water liquid can pass through the center, and from the surface the filters are wrapped, surface the clean air or water will come out. So, this is the principle of cartridge filtration. When it is wrapped, then here the advantage is that smaller dimension. So, we can use this in a very compact place, it is a very compact and also smaller dimension of the filter with regard to acting surface. So, dimension is small, but acting surface we can see it is very high for say water filter cartridge. So, their filter dimension is very high, but it is very compact. So, it results lower air pressure, lower pressure drop, but high flow rate we can get. So, this is the schematic diagram. Here we can see the flat or bulky filter which is wrapped around the this is the perforated drum, and also the pleated filter we can wrap around the perforated drum. Okay. And here you can see for polluted air can come from the surface also, and the clean air is going out. So, this is the air outlet or air inlet, it is there, and also it can be reversed also, but here for air filtration this is better because we can clean the this filter from the outside, and this is the perforated tube is there and filter is in the blue color, this is the filter. So, this principle is applied for cleaning the air in a very compact place. So, induce most of these filters inside car or industrial application. So, inside car the filters we can use this type of filter, and very commonly it is used, this type of filter is used for liquid filtration. Next is the back filter, pulse jet filter system. This principle here is similar to cartridge filter, where the this polluted air will come through the and enter through the surface, and in back filter this cartridge this is the filter fabric flat filter, it is similar, it will form a back type filter which is actually fitted on the frame. We have already discussed this back filter earlier also. However, the bag length is much bigger than the diameter, usually is fitted on the a frame, okay, and it is cleaned by the reverse airflow by pulse jet. Okay. Commonly many back filters are used in one application. So, it is not the only one bag. So, large number of bags are placed side by side to actually clean the large quantity of air. Most of the dust is collected on the surface. So, this is the bag, at the surface the dust particles are collected. when the pressure drop is increasing and it increases its set value. So, there is a set value, the pressure drop can increase up to certain value. So, in that case the pulse jet is created, okay. Reverse air, compressed air flow comes from the inside, in the reverse. In normal case the air is coming from the side and exited from the center, but in for reverse flow. So, pulse jet after reaching the certain pressure drop, the pulse jet is created, reverse air flow, and that will clean the adhered dust. It will get released and it will be collected at the bottom, and also there will be some jet which will give some vibration, that also release the help in releasing this particle. Typical maximum pressure drop is 1000 to 2000 Pascal, that is the typical pressure drop. Maximum typical pulse jet, pulse rate is its range 0.5 to 1 megapascal, okay. That type of pulse we create, and cleaning time is 0.1 second to 100 second. So, with maybe within a minute this reverse air flow goes, and it may be within a fraction of second, 0.1 second, that immediately it will be cleaned, and then again the normal flow will start. So, that way we continuously keep the filter clean, and this is the back filters mechanism here. Okay. Industrial chemical processing, cement industry, textile industry, power generation, where huge large quantity of particles are generated. So, inlet polluted air is moving through this, these are the bags, okay, very large dimension bags, and fitted on the metallic frame, and the clean air is moving out, okay. And during the pulse jet, so the reverse air is coming, and here the output, the captured particles are actually collected here. So, principle of filtration, relation to the relation between filtration variable and filter property, which is very important. So, this is very simple to tell what is filtration, but very difficult to describe the relations between the filter properties and main filtration variable that influences the filtration process. That let us try to understand. So, filtration variables, what are the filtration variables? That is, one is the filter variable, we can get the mass per unit area, we can get the thickness, we can get the fiber diameter, we can get all the parameters related to filter fabric. That variable influences the filtration efficiency, and flow medium variable also it is very important, like viscosity of the medium, flow rate of the medium, that we can that also affect the filtration efficiency, filtration characteristics, and also the particle variable. What is the type of particle? Like it is a large particle, shape of particle. So, what is the distribution of the particle? So, that all these variables which affect the filtration efficiency. which these are called filtration variables. Then depends on the filtration mechanism, what type of mechanism it is following, which depends on the filtration variables also. If the particle size is different, then it will follow the different types of mechanism. If the speed is different, it will follow certain mechanism. If the filter type is different, or its density is different, or any fiber size is different, so then it will follow different mechanisms. And then all this controls the filtration properties. So, that correlation is very important. Understanding this the correlation between all these three verticals is very important. So, if we have certain filter fabric and that filter fabric follows whether it is a electrostatic or diffusion mechanism, that will control the filtration efficiency or pressure drop or lifetime. So, all these parameters are, all these filtration properties are interlinked with the filtration variables and the filtration mechanism. So, clear understanding between all these parameters are very important. So, that we have to understand this. Then the different products are there. So, air filters, so heating, ventilation, air conditioning, HVAC filter, and HEPA filter, high efficiency particulate air, ultra low penetration air, ULPA, air purifying respirators are there, back filter. So, there are different types of products available. For liquid filters also, filter paper, cartridge filter, back filters are also used. So, different types of products available from we can get from the filter fabrics. So, HVAC filter is 3 categories. One is the fiber glass filter. So, fiber glass filter which is very coarse, glass fiber 15 to 60 micron coarse fiber, highly porous, which will have low pressure drop, protect air system such as fans, motors, cooling coils, heat exchange. So, these are the coarse filters. Then plated filters, which we can get from natural fiber, synthetic fiber, and these are usually supported by frame. And then electric filter, so electrically charged filter. So, HVAC filter we can get all these different variants. Now, the category is that we can see the classification, so which is expressed in terms of H10, 11, 12, 13, 14. So, H10 means efficiency is around 85 and H14 is it is 99.99%. So, H14 becomes more stringent, very high filtration efficiency. This is as per the European standard, and then European standard also they have classified, it is called ultra low particulate air, that is ULPA filter. These are usually made up of glass microfiber. So, very fine 0.2 micron or less, and it is following the wet-let method, that filter is made, and where its a penetration is very small and filtration efficiency we can get, it is very high filtration efficiency. It is actually its continuation with the HEPA filter. So, HEPA filter is up to 14 range, and here you can see it is a ultra filtration, it is a finer filtration U15, 16, 17, which talks about almost close to 100% filtration efficiency. Okay. Then coming to the air purifying respirators. So, APR, air purifying respirators, are defined as the device which provides the wearer with respiratory protection against the inhalation from the hazardous atmosphere. So, that is very crucial for human health protection, where very fine particle it protects. So, it is used in face mask, gas mask. So, the face mask and all details will in next session we will discuss in detail their construction and their structural, their different layers we will try to understand, and how they are developed, the historical development, that we will all discuss in the next session. We use the activated carbon. Okay. Activated carbons are very much used to absorb and remove the dangerous chemical, fume, odor. So, that different chemicals it can absorb on the surface. Okay. The activated carbon is used. Now, before we understand the or design our filter fabric, we must understand the atmosphere. The atmospheric particulate matters are there, different types of atmospheric particulate matters are present. Let us try to understand first the particulate matters. So, atmospheric particulate matters, also known as particulate matters PM or particulates, they are microscopic solid or liquid matter suspended on the earth's atmosphere. So, that is, these are called particulate matters. Now, they can be from man-made source and natural source. Like moisture in the air, it is a particulate matter, it is a natural source, but dust or maybe other particle which is generated from the human activity. So, different types of particulate matters are there, and our idea is to arrest all the harmful particles. They have impact on climate and precipitation that adversely affect the human health. So, that we have to stop emitting this type of particle from the source. So, the particulate matters we can divide into different of subtypes. The suspended particulate matters SPM, respirable particles which goes inside, suspended particulate matters, any particles which are suspending in the environment. Inhalable coarse particles, which are coarser particle with a diameter between 2.5 to 10 microns. They are inhaled, that can be stopped here. Fine particles of diameter 2.5 micron or less. So, we can have fine particle, inhalable particle, respirable particle, suspended particle. These are the different ways to express the particulate matter in the atmosphere. PM 2.5 we can express the particulate matter. PM 10, the 2.5 is meant for 2.5 micron and this is 10 micron diameter, that is a size. Ultrafine particle which is less than the this size 2.5 micron. So, there are different types of and suits. So, we can divide, we can actually express the atmospheric particulate matter in all these areas, all these types, that depending on our application we can use this terminologies. Now, first let us try to understand what is PM 2.5. PM 2.5 we use very commonly. The term it is a fine particles, the particulate matter of 2.5 micro, which refers to that the tiny small particles or droplet in the air, that is 2.5 micron or less width. So, very small particle of the size 2.5 micron or less, those are called PM 2.5. Now, for typical air pollution level of a city, the particulate matters are actually its yearly average of particulate matter for 10 PM 10 is 50 microgram per cubic meter and PM 2.5 it is 35 microgram per cubic meter. PM 2.5 means anything below or equal 10 micron. So, air quality index is actually expressed in terms of that PM 2.5 air quality index 35, AQI 35 means the particulate matter 2.5 micron or less, the quantity present in the air of 1 cubic meter is, if we take the total mass, it is a 35 microgram, and daily average can go maximum up to 100 microgram per cubic meter for 10 micron and 75, and yearly average where there will be certain season where the particles are getting settled, like in monsoon the particulate matters and windy area, windy zone. So, there the particles are PM 2.5 will be less. And then what is N95? So, N95 is actually expressed the mask, face mask, it is quality of face mask here. So, N95 it is a US standard which is equivalent in European standard P2, P3 mask, where P3 is offering the higher protection. So, N95 is actually is a mask has particle filtration efficiency more than 95% with a size of 0.3 micron. That is the definition of N95. So, if we take the particle of 3 micron or less size, the filtration efficiency should be, if it is more than 95, then we will call it as N95, whereas N99 the filtration efficiency will be much more. The masks are intended for the the use of the infection for protection from infection, we use minimum N95 masks. So, that our COVID experience says that we need this type of mask. So, in our next session we will discuss a detail of the mask, their construction, how to their the different layers are constructed, that detail we will discuss, and different innovations are there. Electric charge we can use to capture electrostatic charged particles, self cleaning nanotechnology. So, we can treat the outer surface with a nano coating without sacrificing the pressure drop, without increasing the pressure drop, that we can do. Hybrid textile HEPA filter for ultra fine. So, hybrid filtration we can use. Smart textiles with IoT sensor, with a real time efficiency we can use. Bio based fiber for sustainability, that also we can adopt. So, all these things we will be discussing in the next session, when specifically our discussion will be on the mask, different face masks we will discuss. So, integration of wearable electronics. So, all these innovations are there, and we will stop this session now. In next session we will discuss the development of different types of masks and their historical perspective, that we will discuss how the masks were developed. So, till then, thank you.